Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface an HC-12 radio frequency module with a PIC16F877A microcontroller. So, in this tutorial, I will show you how you can perform the communication between two PIC16F877A based boards. One board will be the master board and other one will be the slave board, while the communication media will be 433 megahertz frequency, that is the RF frequency initiated by HC-12 module. Both boards will have one HC-12 module each. One will act as a transmitter and other will act as a receiver. In this way, I will demonstrate to you how you can connect a 433 megahertz HC-12 module with a PIC16F877A microcontroller. And the settings we will be using is the default setting in this first tutorial. So let's get started. So guys, this is the HC-12 module I'm talking about. It is easily available in the market. You can see that it comes with an helical antenna. That's fine. If you want a better antenna, you can buy the IPEX antenna, which will be connected here. But in our case, for the basic, it's good enough. So guys, this is how it looks like from the top. Let me label it for you. So as you can see that it has 5 pins at the bottom here. One on the left, if you hold it like this, is a VCC. The next one is a ground. Then we have RX pin. Then we have TX, and then we have the set pin. Here you can see that TX and RX pin. It means that this is a UART based module. So this means that we will need the PIC16F877A's UART port to interface this module with the PIC. So what I'm gonna do in this video is that I will give you a mini project, show you how to make this mini project where we will use one master board and one slave board. The master board will have its own PIC16F877A microcontroller. It will have its own button. It will have its own HC-12 module, and then the slave mode will also have these things as well. So first of all, in the master board, you will see that whenever the toggle button is pressed, it will send a signal to the PIC. PIC will do the whatever the programming we will write. It will send a command to the HC-12, which HC-12 will transmit over the air wirelessly to the slave board. Another HC-12 will be installed on the slave board, which will receive the signal, and then the slave board will have its own PIC and it will also have an LED. Then in the slave board, the received signal will be sent to the PIC. That is another PIC on the slave board, and then that PIC will, as programmed, will turn on the LED in correspondence with the button. So whenever this button is pressed, it might be at 200 meters away. This board will be in your hand like a remote control. The LED here will turn on and off whenever this button is pressed by following this sequence. So in this way, I will demonstrate to you how you can use the HC-12 module with a PIC microcontroller. So let's get to the connection. So this is for the master board. So for the master board, we will have this PIC16F877A microcontroller having 40 pins. It's a DIP variant. And then we will have this HC-12 module having 5 pins. The left one, if you hold it like this, is the VCC. Then we have ground. Then it is the RX pin. Then TX, and then the set pin. Now you will connect the VCC pin directly with the VCC pin of the PIC like this. Ground will go to the ground. RX pin of the HC-12 module will go to the TX pin of your PIC16F877A microcontroller. That is the pin number 25. And then the TX pin of the HC-12 module will go to the RX pin of your PIC16F877A microcontroller like this. And RX pin is the pin number 26 of the PIC like this. So TX will go to the RX and RX will go to the TX. And then this set pin, you can use any available digital input output pin for the set pin. So I will be using pin number D2, that is pin number 21. Basically, this set pin, you have to put it to the high state whenever you are using the module in any mode, in normal mode. But whenever you want to change the setting, like you want to change the baud rate, you want to change the channel sector, then you have to set it in the AT command mode. For that purpose, you will set the set pin to the low, or you will connect it to the ground. So that is the only function of the set pin. So in our normal case, we are using the default setting here. Whatever the settings come with an HC-12 module when you buy it from the market. In our case, the set pin will go high. So we will send it high by the PIC microcontroller, or you can simply connect it to the 5-volt supply as well. But that's not a proper way of doing it. So guys, this is our master board, and in the master board, as shown in the previous slide, we have a toggle button as well. But before that, we will also need a capacitor for the HC-12 module. This capacitor will regulate the voltage, because whenever the communication is done, it draws 100 milliampere of current at max whenever it is transmitting the data. So at that time, there is a possibility that voltage may fall, causing the communications to break down. For that purpose, you will connect a 100 microfarad 16-volt capacitor in this way. As you can see that this capacitor has two pins, one longer, one shorter, like this. You can shuffle these two pins, it doesn't matter for the capacitor. You will connect one pin to the ground and other pin to the VCC of the HC-12 module, like this. You will connect the ground, one pin to the ground, another pin to the VCC, like this. In this way, your voltage applied to the HC-12 module will get regulated. Now guys, as shown in the previous slide, we will have a toggle button as well here. I'm going to use this toggle button. It has 3 pins. And to connect any button with a PIC microcontroller, you need a 10 kilo ohm resistor, either to connect it in a pull up or pull down formation. So this is our 10 kilo ohm resistor. In the button, we have one pin which is a center pin. We will need this. And on the right, we have another pin, and on the left of the center pin, we have another pin. You can use either of the two pin. We will only use a 2 pin, like this. It doesn't matter, you can leave the one pin empty, either the extreme right or the extreme left, but you cannot leave the center pin empty. So we will use these 2 pins. Now guys, I will connect the one pin of the toggle switch to the one end of the 10 kilo ohm resistor, like this, and the other end of the 10 kilo ohm resistor will go to the ground. Now guys, the pin, that wire between this same pin which we had connected to the one pin of the 10 kilo ohm resistor, I will send it to the any available digital input output pin of the PIC which I want to connect this button. So I am going to use a pin number B0 because it's an also external interrupt pin, and it's a good pin for connecting a button. So guys, it's simple like that. This pin will also go to the digital input output pin, and it will also go to the one end of the 10 kilo ohm resistor, like this. Now the other pin of the toggle switch will go to the VCC pin directly, like this. In this way our button is connected. Now guys, this is the connection of our master board. Now let's get to the slave board. In the slave board, as told previously in a slide, we have a PIC16F877A microcontroller. It's another PIC, and we have an HC-12. This is another HC-12. And this HC-12 also have 5 pins, like this: VCC, ground, RX, TX, and Z pin. We will connect to the PIC in the same way as done for the master board as well. VCC will go to the VCC, ground will go to the ground, RX will go to the TX of the PIC, TX will go to the RX of the PIC. Z pin, you can use any available digital input output pin. I am going to use a pin number D2, like this. Now we will use a capacitor for voltage regulation purpose. Capacitor has 2 pins, one longer, one shorter, but you can shuffle these 2 pins as you like, doesn't matter. One pin will go to the ground, and other pin will go to the VCC of the HC-12 supply, like this. In this way our voltage gets regulated. Now the difference is, here we will have an LED instead of a button. That whenever that button will be pressed, this LED will be turned on the slave board. This might be 100 or 200 meter away. So as you can see that it's a 10 mm LED I am going to use. So this LED has 2 pins, one longer, one shorter. And to connect this LED with a PIC, it's better to use a resistor, because to limit the current, this will act as a safety device. So you can use 100 ohm to 500 ohm resistor. I'm going to use this 220 ohm resistor. Now guys, the shorter pin of the LED is a ground pin. The longer pin will go to the resistor. Now you send the shorter pin directly to the ground because it was a ground pin, and for the longer pin you will connect it to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, you can connect it to any available digital input output pin of your PIC16F877A microcontroller. I am going to use a pin number B2, that is pin number 35 of your PIC16F877A microcontroller. Now guys, in this way our connections are completed. So let me introduce you to the hardware before we go to the programming. So guys, this is one board, and this is the one I am going to use as a receiver board. Sorry. So this is the LED, and PIC is connected at the bottom, like this. If you want the schematic of this board, I can also give you that schematic as well. So this is the HC-12 module we have here. So that is what we are going to use for this receiver board. This is the slave board. Now for the master board, we have another board, and this will act as a master board. As you can see that this has an HC-12, and this is the toggle button we are going to use. So we have both the HC-12 and the toggle button, and same at the bottom is our PIC16F877A microcontroller. Sorry, my Wi-Fi got disconnected. Let me reconnect it. Okay, it's reconnected. So this is the HC-12 for the master board, and this is a toggle button on the master board, and this is our PIC16F877A microcontroller at the bottom. So I can send you the schematics as well. If you want, you can email me. So this is the setup we are going to use. This is our hardware. Now let's get to the micro C for PIC programming. We program them. So let me zoom in. This is our micro C for PIC. Let me zoom in so you can see better. So guys, as you can see that this is version 7.2.0. Click on file, click new project. Then you will get to this window. Click on next. Write the name of the project, HC-12 demo learning microcontrollers. This is the name of the project I wrote. So PIC16F877A is the one I'm using. 16 megahertz is the crystal I'm using. Click on next. Okay, you cannot write this character here, so you have to remove the dash. Click on next and finish. So guys, this will lead you to this window. Before doing anything, press Ctrl S to save your project like this. Click on save. Now go to the right in the libraries, select the libraries you are going to use in this project. First of all, we will need the UART library because our HC-12 works on UART library. So guys, in the UART library, there is a UART1INIT command. Double click on it. This will lead you to this window like this. In the example here, you have this command, copy it. Now the baud rate in this command you can see is set to 9600. For that, let me go to the data sheet. Okay, this is the data sheet of our HC-12 module. I will share this link in the description as well. In the data sheet on the page 4 out of 10, here you have this UART transparent transmission characteristic. It says that it has 3 modes, FU1, FU2, FU3 and FU4 as well. So you have various modes here, but by default the mode is FU3. Factory default is set to FU3, baud rate 9600, and these are our default settings. So whenever you buy an HC-12 from the market, it comes with these settings, that it's in FU3 mode. Whatever the input you give, it will transmit over the channel, and 9600 is the BPS, and 433, that is the channel 1, is already set. If you want to change this setting, then you have to enter the AT command mode, that is you have to change the set pin to the low setting, and then you can do the changing here by sending the AT command given in the bottom of this sheet. But in this video, I will not go into that stuff. I will make another video in which I will tell you how to change these settings. For now, we will go with the factory default. So whenever you buy an HC-12, the new HC-12 always have this setting. So we are going to use a mode FU3, 9600 baud rate and 433.4 megahertz frequency. So let's get to our micro C. Since our baud rate is factory default, so it's 9600, give some initialization delay. 100 will do fine. Now guys, the next thing is we are having UART. This is for the master board. This code is for the master board. We will write another code that will be for the slave mode. So for the master board, what we have here is that we have a button as well, and button is connected to the pin number B0. For that, initialize the pin, press B.F0 equals to 1. This 1 means that it's an input pin. If it was an LED, I was to write it 0. Like in case of an Arduino, you write pin mode, digital input or output. So for input, it is 1. Now give give the initial state, port B.F0 equals to 0. Because we had connected resistor with the ground side. Whenever we connect the resistor with the ground side, it means that whenever the button is pressed, it will send a 1. In the default state, button will be at 0. So initially the state of the button must be 0. So whenever the button is pressed, we get a 0. So this is the initial state, and this is the pin declaration. Now give some initialization delay here as well. 100 will do fine like this. Now guys, we have our button and we have our HC-12 initialized. Now we need the HC-12 to be working in FU3 mode. For that, we have to remove it from the AT command mode. For that, we will program the set pin, and the set pin, as shown in the presentation, is connected to pin number D2. This pin, that is pin number D2. So we program the pin number D2. Initialize, first of all, initialize the pin number D2. So for that, write down trace D dot F2 equals to 0 because it's an output pin. So it will be 0. It is sending a signal, and its initial state D dot F2 equals to 1. Because why 1? Because we want to use in this project the HC-12 module in the transparent mode FU3. If you want to use HC-12 module in any mode, the set pin must be high. Set pin is only low when you are using when you are changing the setting, like it's in AT command mode. So in our mode it must be high. Like in normal mode, the set pin is always high. So this is our set pin, this is our button, and this is our, you can say that, HC-12 initialization. Now we can go to forever loop. Write down for the master board. So let me write down, this is for the master board so you don't get confused. Master board code, like this. So forever loop starts here. Write down while one, starting bracket, and the ending bracket, and this is the void bracket, making it like this. Now guys, the first thing is we want to send a signal whenever the button is pressed. So button is at B0, so we write down if port B dot F0, copy this here, double equals to 1. It means that whenever the button is pressed, by default the button is at 0. So whenever the button is pressed, we get the 1, and whenever it's 1, what it will do? It will go to the UART library. Here you have this UART write. Click on this and write something. Whatever you write, you have to read it in the slave board. So write a letter called A, this, and otherwise whenever it's 0, write down else if, and whenever it's 0, what it should write? It should write B, send a B. Now in any other case, if there is any other state, write down C, like this. Now what is going to happen is that whenever the button will be, toggle switch will be like pressed in one direction, it will send a letter, and in the slave board we will read this letter, and we will read in a way that whenever A is received, turn on the LED, and whenever B is received, else, or else. If there is no A is not received, only whenever A is received it will turn on the LED. In any other case, it will not turn on the LED. So this is our code for the master board. We build it like this. It's built successfully. Now we burn it. Okay, this is our port D.F2. For safety purpose, also write it here as well, that the set pin after every loop it should make it high. So it must remain high in the whole code. Usually it's enough, but for safety you also write it here. Now we burn it in the master board, then we write the slave board code. So we open our PIC16 programmer software, and let me connect the PIC. So it's connected. Go to file, import. This is the code. Click on write. You can see that the new code is being written in the master board. It is writing the code in the master board. Okay, it's written. Now we remove the PIC and we connect it to the slave board, because we want the next code to be burned in the slave mode. We go to our micro C for PIC to do the programming. Now let's zoom it. Go to file, new project. Just add 1 in the end. So it will be the slave board. We have PIC16F877A. Crystal is 16 MHz on slave board as well. Click on next and finish. Now again, before doing anything else, press Ctrl S, save your project. Now go to the right, select the libraries you are going to use here. Expand these libraries, write UART. This is the library we are going to need here. check mark it, then double click on this UART1I and IT command, go to the example. In the example you have this command. Again the HC-12 connected on the slave board as well is in the default state, so it means that its baud rate is 9600. Give some initialization delay, 100 will do fine. Now guys, the next thing is, in the slave board we have an LED at B2, so write its code tris b.f2 equals to 1, sorry 0. 0 means output and 1 means input, and initially the LED must be off, so we write down port b.f2 equals to 0, that initially the LED is off. So we give some initialization delay, 100 will do fine. Now again guys, like we had there, we have a set pin here as well at this d.f2. We simply copy that from there, from the master board like this. And let me also highlight that this is the slave board code. You copy this, paste it above the void main like this, and write down slave board code like this. So guys, here we have our HC-12 initialized, we have our LED initialized, and we have the set pin set to high because we are going to use the FU3 mode that is set by default. And now we will go to the forever loop, write down while one starts here and here, and write down the command. Whatever we were sending here, now we have to receive here. So whatever you were sending in the master board, we have to receive there. So what we do is that we go to the right. In the UART library, you will see that there is UART1 read. Double click on it, and in the example you have these commands. You copy them till here. Go back, right, paste it. This receive is the variable which will store the received command. So you write char, because we are sending char. See here we are sending a char. This is a character, basically it's a char type. So you will make a char variable which will store the data. So receive will receive the data, give some initialization delay, so it can receive data fully, so we don't get a rag back value. It will be 20 will be enough. Now whatever the data is received, 20 will be enough. If we write down receive, it is to be this variable, whatever you write the name of this variable, receive double equals to a, like this. If the character received from the HC-12 module is A, this means that whenever A is sent, what should happen? It means whenever the button is pressed, only then the A is sent. It means that the LED must turn on at this stage. So LED is at port B.F2. So we copy it, paste it, and turn it to 1. So whenever A is received, LED will turn on, else if anything else is received, LED will turn off. So we make it 0 like this. So whenever A is received, LED is on, else LED is off, like this. And again we do the same here for the set pin. For the safety purpose, we also write it in once enough forever loop. So it will keep the set pin high, because for the set pin to be high is very important, else your module will not work. Now we have the slave board code as well. We build it, check for errors. There are no errors. Now we burn it into the microcontroller. So let's zoom out. Go to your PIC16 programming tool. Go to file, import, and this is the next code. Click on write. The new code is being written. Let me show you. You can see that the new code is being written. Now code is written in both the devices. Now I will power them up using a battery, or you can use a 5-volt source, because you will need a 5-volt source for both the boards. So let me power them up. So guys, as you can see, I had powered up both the boards, one with a PIC and another one with a battery. So you can see that on the remote control board there is a button, and this is the LED at B.F2, which will turn off when I press the button. You can see that LED starts blinking. It means that our communication is working, it's on. Now I turn it in the opposite direction. See, it stops. This LED has stopped. Now again I press it. See, it's pressed. The LED is working. See that? It is working. Now what I do that is that I stop. See, it has stopped blinking. Now this blinking is because the communication is done in packets, in BPS. So you can write various codes to make it useful, like you can hold a bit whenever a bit comes, use while one to hold it. And these are the various techniques, but the communication is working as expected. See, when I press in the other direction, stops. See, it starts blinking, and when I press it in the other direction, it stops. Now this range is very good. You can even penetrate through the walls. You can use various tests on the range as well once you make this project. See, you can also control your vehicles, your robots, your drones, etc. with this technique. See, I press it, it turns off. When I press it again, it turns on. See. So guys, our communication is working as expected. I hope you guys learned something from this video. Thank you very much for your time and have a nice day.